So welcome back to this second part of the Hexa-X-II series workshop, and we will continue with the presentations. The afternoon session is split into two parts. So first 1 hour now, and then a long break, and then the last presentations later in the afternoon. For this session, we'll focus on the architecture and the end-to-end system view. And first off is from Hexa-X-II with Sylvaine Kerboeuf. Sylvaine, if you are sharing.
Yes. Can you hear me?
Can hear you.
Can you see my slide? I'm trying to switch to the presenter mode.
Yeah, let's see. Normal view, not presenter so far.
Okay. Now, is it good?
Still see normal view, not in presenter.
Still normal view?
No, it's presented.
No, it's good. No, it's good. Yeah.
Okay. Okay. Thank you all. So I'm Sylvaine Kerboeuf. So I'm from Nokia and acting as the work package lead of end-to-end system in Hexa-X-II. And in Hexa-X-II, we envision a 6G system as a platform that go beyond just communication services, and that is built from multiple actors of the 6G ecosystem. And this vision is driven by a commitment to both performance and value development, prioritizing economic, environmental, and social sustainability. And to achieve this ambitious goal, Hexa-X-II has employed comprehensive design methodology that combine both a top-down approach, where we want to derive the system blueprint from the 6G system requirement, and also 6G system design principle. And on the bottom-up approach, the technology enabler are developed and analyzed for ensuring their seamless integration in the 6G end-to-end system blueprint. And this is an iterative process involving continuous enabler refinement and enhancement to the overall system blueprint. And also, to demonstrate the feasibility of this design, we are developing some system proof of concept to validate early evidence of the 6G capabilities. And in this presentation, I will mainly focus on this 6G system blueprint. This will give a first glimpse of our final system design that will be released later in April. Moving first with this architecture design principle. So in Hexa-X-II, we have defined 10 design principles, and this design principle are mainly focus on this key value and realization of environmental, social, and economic sustainability. And they are crystallized around 3 top priority principles that are the network simplification in comparison with previous generation, and also the security and privacy as the first thought in design, and the minimization of the environmental footprint. And then, building on this design principle, we have defined the 6G system blueprint with mainly 4 layers. The application layer that is representing the end user and the application from enterprise. There is this application enablement platform layer. to interact, to enable application to interact with network and the 6G capabilities, providing mainly abstracted API, and also management and operation API for acting on the 6G capabilities. And the network layer feature also a single RAT architecture for 6G and extends the 5G core, introducing some new functionality, especially for the beyond communication services. And the infrastructure layer encompasses the cloud continuum from cloud to edge and to device. And on the right-hand side, you have this pervasive functionality that supports all the other layers. And it includes a high framework, data framework, as well as pervasive privacy, security, and resilience, and management and orchestration, including intent-based management and also closed-loop control automation. And there is also this service exposure framework that reflects on the programmability also of the network, enabling control over the 6G network capability, and as well as exposing management services that was previously mainly used internally. And finally, this system blueprint acknowledges the importance of the multi-stakeholder ecosystem, recognizing the increasing disaggregation of the market and the need for collaboration between various stakeholders in this 6G ecosystem. Of course, this system blueprint provides a comprehensive overview of the main key feature. But then we need to go deeper into specific system view that we have introduced to offer some focused perspective on the various aspects of this overall system blueprint. And now I'm going to delve into those details. So we start first by the migration path, and we have started from the lesson learned from migration to 5G, and that is to limit the number of options. And so this is why we argue for having a 6G standalone from the beginning, with a core design in 6G based on evolution of the 6G core, and also having some 6G network function and share network function. And for the facilitation of the interworking and migration, multi-RAT spectrum sharing is option preferred, as it allows more efficient dynamic use of the spectrum between the two generations. And we also anticipate a shift from the higher level split that is used in 5G towards a lower layer split in 6G RAM, as it will allow to support advanced technology like distributed MIME. Now looking at the integration of the beyond communication services, so a crucial role here is having a service exposure framework to enable the exposure of 6G services, and also the ability to have a programmatic control of these 6G capabilities through API. And a crucial role is also held by this application enablement platform layer that allow to provide API to application, and also a set of tools like a developer portal, also some O&M services for easy API discovery and so on, and also functionality for monetization and authorization and regulation compatibility. And looking now at the impact of these novel services on the 6G blueprint, so to integrate those beyond communication services, we have introduced several new functions in the system. For example, having this sensing unit function in the UE and in the RAM, as well as the sensing management function for providing for providing this sensing as a service services. There is also these AI as a function services that allow to expose AI services to consumer, could be internal consumer or external consumer, and the purpose of these AI services that are offered is having this AI model as a service, or having some trend inferring result exposed. And also related to the compute as a service aspect, so we have this we have this compute management function that is introduced in the NATA network, and it could be inside the network handled by the operator or from a third party. And also for this processing offloading, where application on the user equipment will require offloading processing to some compute resource at the edge. Here we foresee a loose coupling with the network, so having some new function introduced in the application enablement platform layer, with some function in the node, in the UE and in the data network, also to manage this processing offloading. Then moving on, another aspect of the system view, this is about having a comprehensive approach to radio protocol and interface, also investigating how efficient we can be with respect to energy consumption, and also providing a more intelligent and user-centric network. And this view detail indeed some enhancements that we have done for the radio protocol. Sorry, I have some issue with my mouse. And this indeed focus on enhancing radio protocol, looking at the enhancements for application and network interaction, especially for improving QS and QE. Also looking at mobility management enhancement, and also looking at how radio protocol should support the new service signaling for sensing, for AI, and so on. And this is also, there is also some work in Hexa-X-II on providing a flexible design of the physical layer, and having also some advancement in transceiver architecture, as well as advanced system on chip system. And I won't detail here because tomorrow you will have more detailed presentation from Hexa-X-II other work package. So looking now at another aspect of the system view, it's that the network will embrace flexible access and topology. And it means that it will integrate satellite communication, allowing UE to connect to both satellite and base station. And also for the satellite, there will be multi-hop routing thanks to this inter-satellite link. We also introduce some network where UE can act as a management node for communication within the subnetwork, and having various procedure for coordinating with the overlay cellular network. And there is also some UAV-based multi-hop backhaul that can be used so that you can have flexible and on-demand network extension in area with limited infrastructure availability. And the last point is this multi-connectivity, where a UE can connect simultaneously to a WLAN terminal or the terrestrial base station. Now, looking at how we can explore the support of this complex ecosystem that underpins 6G, where multiple stakeholders from technical company, operators, vertical industry, and resource provider need to collaborate together to deliver digital services. So indeed, this system blueprint view illustrates how entity from different administrative domain, like this intent-based service manager, the service orchestrator, or the resource manager, can expose their API for ordering service, orchestrating service, or managing resource. And the key for the collaboration within this context is that there will be this concept of federation API that enable the sharing of diverse type of resource. It could be network, it could be cloud, it could be AI application. And also important is that there will be a single federation interface that is able to support different models. It could be just peer-to-peer federation interaction, or rather having some kind of brokering. And what is important is also that this federation API can happen at the resource level for sharing more efficiently resource across various stakeholders, but also at the service layer with providing service to each other in order to compose some more complex services. And of course, to facilitate all this exchange between the service API, federation API, there will be this controllable capability exposure that allow to seamlessly exchange through this various API. And there is also the intent-based API on the top, but also can happen at the different service level or resource level. And this intent API is really to simplify the interaction for service ordering. And a same API can be used for northbound interface or east-westbound interface. So either for requesting the service directly by the customer, or for setting some service requests from a partner to another through this east-westbound interface. So another important aspect of the system view is the focus on this AI native architecture. And of course, a 6G architecture will integrate AI ML in every layer of the network. And it starts from the applications that will request some AI power services. And then the application enablement layer can act as a mediator to enrich with AI-driven context and routing also to the appropriate network element. And in the network function, it will also leverage AI to optimize the wireless access for data routing and so on. And even the interface will be based on AI. And at the heart of this architecture, there are this AI ML framework that is a suite of tools that provide key functionality, like this AI orchestrator for managing AI service deployment and lifecycle. There is also this AI ML catalog that will act as a central repository to store all AI pre-trained model, and also this MLOps orchestrator that is in charge of managing the end-to-end life cycle of the AI ML model. And also important, there is this data management function that has a central role for managing effective collection of distributed data, processing them, and also looking at the governance of those data, ensuring also adherence to regulatory requirements.
If you can start to wrap up.
Yeah. So this is the last view. This is the last but not the least. It details all the aspects with security, privacy, and resilience control that we introduce in this 6G system blueprint to look at the various features of this aspect of security, privacy, and resilience. And all those controls are indeed some key components that are acting at every layer of the system blueprint. And mainly, for example, we've got some confidential computing for the infrastructure layer. We've got also some physical layer security or security and trust and privacy mechanisms for sensing that are introduced in the network layer. And also this new beyond communication function as trust and evidence that provide, for example, level of trust assessment function for trustworthiness of the network service, or notary services that help to have a common reference for identity or cryptographic features. So this will end my presentation. So just to briefly give a key takeaway. So we have built inside Hexa-X-II this holistic blueprint of the 6G system, relying on principle crystallized around simplification, security, and privacy, and also sustainability consideration. Of course, we've got some validation of system POC and also looking at several complementary SNS JU enabler coming from other projects, but this was not the focus of this talk. But anyway, in case you want to learn more on our previous deliverable, these are the link, and there is also these two new ones that will come soon. And this will end my talk. Thank you for your attention.
Thank you very much, Sylvaine. And if you have any questions, please post these directly in the chat. In the interest of time, we need to move on. The next speaker is from Next Year Alliance, Devaki Chandramouli.
Hello, everyone. This is Devaki here. Can you hear me?
Yes, we can hear you.
Yes. Let me share my slides.
See your screen now.
Very good. Thank you.
Thank you.
Very good. So I will present Next Year Alliance view on the system architecture. The Next Year Alliance had a recent publication on 6G wide area cloud, and I will present our findings from there. And I also represent Next Year Alliance as a steering group co-chair. Thank you. And from 6G wide area cloud, the vision is to holistically integrate the communications and compute to meet the demands of the new applications by merging the two distinct objectives, which is the cloud concepts that started in 5G to be more efficient, reliable, and cost-effective already, but also leveraging the mobile network to integrate the compute resources for a richer and a more dynamic cloud services. to the application. So the mobile network and cloud architectures, as we know, have evolved independently, and the centralized cloud model to put to a heavily distributed 6G system is envisioned as we have, wide range of applications for sensing and other services to consume vast amount of data. And the other use case that we also see is offloading computation due to significant demands of these compute-intensive applications. But in order to keep the devices with low power, then we also need the ability to efficiently offload the compute. And in this case, we also need to be able to discover the compute capabilities dynamically where it is available by the device. From an overall architecture perspective, here we leverage the cloud computing technology, of course, not to the maximum extent. But with the 6G wide area cloud, we expect it will be comprised of intelligent, ubiquitous computing, communication, and data services, either in the regional data center or in the metro data center or in the centralized data center. So it can be like a compute anywhere. So it can also, of course, be supported in the devices or even the cell sites. So it can support both the 6G system functions and also the application as the workload. This is basically one aspect that we believe that may be introduced to the cellular network, which is the computing and the data plane integration. And then we have convergence of cloud capabilities with the 6G system. On the left-hand side, we see the evolution of the network architecture. Here, the cloud compute enables network access to scalable and elastic pool of shareable physical or virtual resources that can be self-provisioned and also administrated on demand. And the convergence may include adopting the cloud infrastructure to enable the computing workload distribution, to share also the heterogeneous resource, enhancing the system capabilities for both orchestration and also offering joint communication, computing, and data services. So in the subsequent slides, we will see where we are with 5GS. In 5GS, it's the cloud computing capabilities are not yet totally integrated. Of course, we do have edge computing. The edge computing offers the content which is closer to the user, but here we can go beyond that. I guess the computing and the data services are generally outside the mobile system domain in the case of 5G, but in the case of 6G system, we expect to likely incorporate also the data-centric services, computing to support also sensing, and then also AI-powered applications where we can also have like the devices leveraging also the network for machine learning capabilities and the compute required for machine learning capabilities. And then here we can we also envision offering data management as a service for the 6G wide area cloud to become more intelligent and with personalized and predictive services. So there can be massive amount of data from the device sensors, network measurements, status, and applications needs to be securely distributed. the examples include data such as device mobility, application usage, and also interest level to predict future patterns. JCAS data can enable multiple services, including area monitoring and also object detection. So this data distribution for AI ML model training and inference will enable the 6G wide area cloud to help learn, predict, and also adapt to achieve the customized services, and also enables orchestrating the compute and the storage resources more dynamically. So here our key takeaways is that it's a 6G wide area cloud will continue to integrate the cloud concepts into the network that began already in the 5G days, but will leverage the network to integrate also the distributed computing resources. Network functionality should be like any other application workload handled by the cloud resources. The network can be envisioned as a vast array of sensors, users, applications, and services that will consume vast amount of data. So we should leverage the 5G system capabilities and also the computing technologies for maximum reuse, but eventually offer also, the intelligent and ubiquitous computing, communication, and data services anywhere. I guess either in the regional data center or in the on-premise equipment or the devices. So it'd be more depending on the deployment needs. So that concludes my short overview on the wide area cloud. Thank you.
Thank you very much. Very brief and very concise. If there's any questions for Devaki, I think we have time for one or two. Mitch, you can take it online.
Okay. Yeah, thank you, Patrick. Thank you, Devaki. Good to see you here. This topic, of course, we understand that it's a very good concept, but then the only thing I'm not quite sure is that does this require standard work, for example, in 3GPP or not? And of course, you understand very well that in Next Generation Alliance, we do not contribute to the standard work, to the standard directly. So it will up to like Nokia or other members who found this interesting to take it to the standard bodies, right? Thank you.
Right. Yeah, very good questions. Yeah, the number one, it's a highly debated question. Yes, the question is whether it needs standards work. The aspect that needs potentially standards work is finding the right entity or the right data center where the compute is being offered. So for instance, the discovery and selection aspect. So that could potentially require standards work. The actual compute itself is more implementation specific. That would not require standards work, but it is mainly the discovery and the selection part, especially if it is from the UE to find the right cloud and the right UPF to terminate the data connectivity would require standards work. The other question, yes, of course, in 3GPP, no organization can directly contribute. Rather, it is via the member companies, and the member companies, the interested in a certain concept, of course, can directly contribute to the 3GPP. Yeah. But there is quite some interest that we also see among the players in 3GPP for this kind of functionality.
Yeah, thank you. Yeah, I do see that this actually works quite well with the previous discussion. Also for Nokia, Hexa-X-II, this focus on network functions. That's very good.
Yeah.
Thank you.
Okay. We have time for one more question if there's any. Seems not. So thank you very much
Thank
for
you very much.
presentation. And moving on into the agenda, next speaker is Liu Guangyi. I don't know if it's online.
I also did not recognize in the list, and also doesn't seem to be raising his voice here or hand.
If so, I think we should take one presentation from the next session, move it here. And I don't see neither Takehiro or Jaydee in this attendees list, but Mårten present from Hexa-X-II then.
Yes, I can do that. Am I the presenter or?
Just a moment.
Yeah, so the presentation will be Hexa-X-II, the architectural enablers for 6G by Mårten Ericson.
Oh, there, share. Yes. So hopefully you're not disappointing on seeing me instead. Hi everyone, my name is Mårten Ericson, leading this architecture enabler design work package in Hexa-II. So we'll talk a little bit about the enablers we're doing here in architecture. And I will say that also we have a little bit overlap, especially work package 2, but so sorry for that, but that's natural, or how it should be, I think, a little bit repetition, but not too much. We have 5 different areas in architecture work package. We have been driving, and we think that there's a main important areas that we should improve the architecture. Let's see. We have the AI and data-driven architecture. Of course, we need to have that in 6G. New access method and flexible topologies. We need to be a little bit more flexible in 6G. Already started this in 5G, but can be a little bit more better there in 6G. Then we have an area called networks beyond communication. That's basically sensing, compute. It could be a little bit other things also, showing that a little bit later. And then we have 2 different architecture areas. This network modularization is then dealing with how the network functions should be designed in 6G. Can we do it better? What interfaces do we need, and so forth? It's a big, quite 3D-PP oriented, we almost say, area, this one. And then we had the cloud transformation is then how to improve the cloud for the 6G needs. So I will start with AI, and this will be a little bit repetition from Sylvaine taking off now. Maybe you already have it fresh here, so I will be a little bit quick. So we start with this blueprint just to show this is very good. I was wondering how I would describe the AI as a service enabler, because that's one of the first enabler I will present here. The way to do this is, of course, to present all other enablers, because the AI as a service is the some sort of the connector for all other enablers. And as Sylvain also said, you can deploy as a service the function a little bit everywhere. Here is an example in the core network. As a service, then it serves this, as I said, a one-stop shop solution where you can handle the deployment, execution of your services. And this also exposes this via open APIs. You need to have some models for that, and that's ML operations ops. ML ops take care of the ML models and update them and handle them. That's a second enabler here, ML ops. And then lastly, we have the data. Here it says data, but it's data ops as an enabler name. And that is, of course, as also Sylvain said, to collect the data. So these are the three enablers, and as a service is basically the connector of these ML ops and data ops. and serving as exposing these the service to via open APIs. I will be a little bit more about the MLOps and DataOps, starting with DataOps. How this was exposure. So very quickly, we have some couple of studies there talking about as we said, I think you know this, DataOps is how to integrate how the integration with the collecting the data in the network, and also processing and send it to the other MLOps and other functions. So one thing that is important, of course, is this privacy preserving. So we work with that to ensure privacy in this data collection. We have other studies doing here. Another interesting study is then more application using this data ops or data collection, using it for some in-network analysis. And this is an experiment where we try to predict failure in the core network, in this case the 5G core network. It's called 5G core observability platform. So we have the 5G core here, and you try to collect the data of latency, packet losses, or whatever, and you put it there. You have the data framework, you try to collect as much as you can and put it to the AI framework and try to predict failure. And the results show that you can do that, but it's also rather costly to collect all data, of course. It's something we have to work more on, how to collect data efficiently. And then we have MLOps. I think this is maybe the most popular research topic in this work package. We have a lot of studies here, so I only show 2 of them, rather different ones. So to the left, we have a concept how to do the life cycle of the ML models. And this is also input to 3D-PP. How they should be updated, how you work with them, and so forth. So, and the next one is completely different. It's more the application, how you can use ML in the network, and this is rather been used. This scenario has been used a little bit quite often in these MLOps studies. That you have this hierarchical view here with servers and compute services, you have users and so forth, and base stations, of course, also. And then you try to optimize the energy consumptions or power consumptions or whatever. In this case, where the figure here shows, is actually optimizing the transmit power in the uplink. So it's a very traditional way of and it shows that it's possible if you have knowledge of these using federated learning, you can actually optimize the transmit power compared to a more traditional power control. Then leaving data-driven architecture, we go to these beyond communication services. So we start then with compute offloading framework, and I guess this is a little bit interesting because it has some with the previous speaker some connections. We have a little bit similar concept, I would say. And to the left, we have the framework. It's a little bit messy, I hope you can see, but you see this. This is the UE. And here we have the RAN and core network. And here we have what we call the offload cluster. The blue is then the new functions for enabling compute. So in the UE, we have to have some offloading node functionality and some way to find the functions modules that you want to offload. So which UE cannot really handle by themselves. And then you have in this offloading cluster, you have compute control, and you have also can find the resources and resource management and so forth. And as you see, it's not in the RAN core network, it's outside, it's over the top, so to speak. It's loosely coupled, similar to SA6 HApp concept, which is heavily inspired by. But as the previous speaker also said, we need to have procedures for compute here, so like service discovery, how you actually offload and so forth. So we have developed also these procedures, not every procedure perhaps, but a few of them at least, and one of them you can see to the right here. So this is an offloading node, the UE, that tries to register to this compute control node. And this offloading node can also be, in this case, can actually be a resource, computing resource. So it can register to be a compute resource. So we don't distinguish here. And then you also have to have the registered on the, yeah, as an example, we have several procedures developed here also. And this has to be standardized, maybe not the, maybe not in 3D, probably 3D, but it doesn't have to be some round 2 specifications, can be a little bit outside. So via this concept can be a little bit faster to develop, we think. Then we go to the sensing framework. And the sensing is, as you know, we try to find the objects in the environment. We try to sense buses, cars, and whatever, where they are. That's the idea with the communication resources we have. We found out that we need 4 different functions, at least 4, for this to work. We want to, first we need some sensing request functionality. So when there comes a request from any user or application here, we need to handle this request and understand what it means. We need to send this request then in a better to this sensing management function here, and the sensing control. The sensing control try to find the sensing units, as also Sylvaine talked about. This is the pink lines here to the base stations, trying to do if it's what type of sensing it is. Even a UE can be involved here. And the green lines is then the actual measurements up to the sensing processing. So the processing we need to do also, and we have to expose it then also after that. And we also here it says user plane, data plane. It could be a new plane, but we are not sure what we think. It could be more beneficial to have a. But as it is now, I think a user plane is the to send the measurements. There is the first step at least. Then the protocol, the signaling looks quite similar. I said most of it's a little bit repetition, but still. So we have something coming from an application going via the NEF to the sensing management function. So this is you see what type of request, they call it a service and things like that. And you need to check the privacy authorization, you select the method, you find some sensing units, sensing entities. I think sensing units we usually use, and we configure. We find the configuration and send the configuration both to the base station, maybe to the UE also. And they do the sensing procedure and send up the measurement back again to the sensing management and processing this. Here we can see that the processing data doesn't have to be, it looks like it's in the core network. It could equally be done in the base station. So this sensing process is maybe it's even likely that it will be done in a base station, but we haven't really. It's nothing we have decided here where it should be, but just saying this. Then we send it, expose it. So this is then the sensing framework. Let's see how much time I have. Great. Leaving compute and sensing. We have a little bit then going to architecture issues here, and I will do a little bit migration aspects here, also repeating a little bit what Sylvaine said again. So what the interworking we see between 5G and 6G is multi-rate spectrum sharing. We had the dynamic spectrum sharing between 4G and 5G, worked pretty well. The overhead was so and so. But we have investigated the overhead for if, assuming 6G is unloaded, there is no really users in the 5G spectrum, and found that the overhead for 5G is sees is extremely low. It's very low. It's a couple of 1 or 2%. So the minimal overhead, of course, it will be more when they have more users in the spectrum, of course. But the overhead unload is very small, and it's very small for granular use of using spectrum. 60 can get hold of low frequency spectrum and get good coverage and so forth. Backup for this is, of course, inter-rat handover. We need to have that. This figure also showed, I think maybe Sylvaine showed this also, that you have MRSS between the 5G and 60 cells. And here you can have corrugation between 60 cells, but not. And then you have one core network, which comes to the next figure, that it should be involved core network, and I think Sylvain also showed that. And we also investigated other interfaces, the N2, evolved N2, and a little bit about these other functions. So I just briefly say that we investigate that the N2 it's M2 in 5G, but it doesn't have to be called like that in 60, of course. But we think that plays an important role, this interface between RAN and AMF, and they should be kept because of migration issues, security issues, and it's most evolution from 5G to 60. So this is option A, then, is our primarily option for 60 also. We have also investigated using service-based interface and some hybrid solution, both service-based and N2, but we ended up in preferring only N2 and enhanced N2, more cloud-friendly protocol there. Then a little bit flexible topologies. We have them here. We worked a lot about subnetworks. Subnetwork to the left, we see this small subnetworks, private networks perhaps, where some is called management node here, where a capable UE takes care of some of the functionality from a less capable UE in order to save battery or functionality for these UEs. So we have a very detailed procedures and protocols how that could work out. On another type of subnetwork, rather different, is then using drones or UAVs to extend the coverage in an ad hoc basis, perhaps, and using multi-hop between the base station and find to increase coverage for rural area. Then we did a little bit investigations in multi-connectivity and satellites, showing a little bit results here. We try to find where is the gains from corrugation. We investigate this and find it's not corrugation. The carriers have to be rather equal in terms of coverage and capacity and bandwidth to get good gains. In this figure, you just get like 10% gain with corrugation, and the big gains you get by doing densifications actually, and not corrugations. And then we also worked a little bit with satellites. So here it's actually how do you see the coverage? What is coverage? And this is a way to measure the coverage in a better way. Something called inequality index here, which we have been promoting to see the coverage. We also have something called optimal placement, where you move the functions around in the network in a smart way. The first to left here is something called optimal placement, integration network and compute, INC, which gives a high improvement in both latency and power consumption. And to the right is a POC, actually, where you offload different layers from application to the network, and you can save a lot of energy, 70% in energy here. Then lastly, cloud transformation is then the last one. I will just show one enabler here, and it's this multi-domain, multi-cloud federation. The purpose of this enabler is to provide a more homogeneous type of cloud that you can manage multiple cloud and they see them as one, and you can reuse the resources in a better way. Instead of having different type of clouds that are completely separated, an operator has one cloud in each country, you can combine this cloud and the seamless user experience, as it says there. Applications may be easier to make them work as you do in home country and so forth. This is, of course, has a lot of improvements for the special operators if you can do it like this. So there are a lot of protocols and investigations about that. We have some experiment results in this area, not about this multi-cloud exactly, but how the power usage also by the different network functions. So just to see, we have some experiments there, simulations there too. Now I think we wrap up. The summarize what we have is what type of enablers we have that will drive 6G to be successful. So we're in the AI and data-driven network. I have these three. We need to have them. AI as a service, MLOps, data ops, flexible networks. We need to have better sub-networks. We need to integrate satellites better, new improved multi-connectivity, and we also have some work about improving the transport. We are context-aware transport, call it. Sensing, we have shown that we have sensing protocols and frameworks for both sensing and compute. We also have showed that these optimal placement functions is also could be an important factor for improving 6G. Architecture-wise, we think the 5G system migration should be handled by spectrum sharing. And we also think the lower layer split, I forgot to say that, is an important aspect of 6G and not the CU-DU split. We think that we should have an evolved 5G core for 6G also, so we can leverage on the 5G core network for 6G. And the functionality should be more modular. We have some studies showing this also, that how to improve this, which I did not show this time. The cloud should be improved. We have the multi-cloud federation as one example, where we have others, extended MEC and slicing and so forth. I think that's it for me. Thanks. Right on time, I think, or maybe a little bit late. Thanks for this.
Thank you very much, Mårten. So we have 2 minutes left of the session, so time for one quick question. We have in the chat the questions. The first one is data ops only for the core network?
No. Maybe it was a little bit obscure there. No, it's not only. No, it's down to the UE even. Yeah. Now I don't. At least in our concept, we don't limit it only to be core network. It's definitely RAN and UE too.
Yeah. Then there's the question here: the federated learning, is that still an AI problem?
Yeah, exactly. Just one way to do AI is federated learning. Yes. Yep.
Yeah, and then a question on that. These presentations from Hexa-X and Next Gen Alliance are more focused on verticals other than the network.
Yeah, I think so. Actually, it's a point there. I think that we are much more vertical oriented than we used to be, at least. So less network oriented. So we have a little bit both, I would say. But
yeah, and the final question is cloud core a must for the architecture?
I think we should at least be aware that the cloud will be important. So we need to adapt the procedures to be cloud friendly. But of course, we should work. If you don't want to use cloud, it should work anyway. The procedures and things like that. So, but cloud core, maybe it's not a must, but I think it's very important.
Thank you very much. So this top of the hour. And now we have a quite long break until the next session. It's an hour and a half, and we will start again at 3:30 Central European time. So thank you all speakers, and thanks to the audience, and see you in a while. So welcome to this last session for today of the Hexa-X 6G workshop series. We will continue with presentations from around the world. First presentation now is from Japan with Takehiro Nakamura from entity DOCOMO and the XG Mobile Promotion Forum.
Okay, so can I start now?
Yes, go ahead.
Okay, I will share my screen. And okay, so thank you very much for inviting me to this great event and Hexa-X-II workshop. And I was asked to provide information presentation on the Japanese situation on the 6E activities. So actually, I'm leading one of the project in the so-called XCMF, 6E related organization in the Japan. So I'd like to explain the XE Mobile Promotion Forum overviews. Yeah, actually, before establishing the XG Mobile Promotion Forum, we had a 6E organization, so-called Beyond 5G Promotion Consortium in Japan. That was established in December 2020. And in this consortium, we developed a white paper and published. And yeah, and also we had an open run promotion activities also, and they published report document also, and other many activities conducted and provided some papers officially. But and also in Japan, we had 5G promotion activities, 5G mobile communication promotion forum, 5G MF. Of course, most of the 5G activities are completed, but still we have some necessary activities on the 5G promotion, such as millimeter wave promotion and also local 5G, private 5G promotions. And also, yeah, we had a Beyond 5G Promotion Consortium, mainly focused on the 6G topics. And in order to have a efficient research and discussion strategy and activities, we decided to incorporate the two organizations, 5GMF and Beyond 5G Promotion Consortium, into XG Mobile Promotion Forum. XG Mobile Promotion Forum, XGMF, was established in April last year. And chair is, we had two co-chair, Professor Morikawa, Tokyo University, and also Professor Nakao, also Tokyo University. And also currently, number of the members is 179. So many ICT industry people, and also some vertical industry companies are joined in this organization, new organization, XCMF. The XCMF goals, especially for the international relationship, is sharing the 5G, 6G global information. Of course, we need to gather and share the global information on the 5G deployment and the 6G technology developments and so on. And also, we need to disseminate the 5G, 6G information in Japan. And also strengthening the international coordination, building consensus in pre-standardization activities in preparation for the full-scale launch of 6G standardization activities. So yeah, as you know, the 3GP and the I2O started their 6G standardization activities, and it is good if we can have a good activity and achievement of the pre-standardization activities as a result of the international coordination. And the third one is promoting the international industry academia collaboration. Yeah, industry academia collaboration is very, very important in Japan, and also, of course, international manner. And building the human resource network for international industry academia collaboration, such as organizing the 5G, 6G event and the academic conference in Japan and overseas. These three is the main goal in the international national relationship in XCMF. We still have a global collaboration partners like this, many 5G and the 6G organization, and we are discussing and coordinating to start the collaboration with these kind of 6G major 6G organizations in the world. And this is the XE organization structure. And we have a unique approach in some sense. We don't have any committee structure or working group structure. We have a organization based on the projects. And the project is the unit of activity establishment. It established based on XCMF member proposals for each mission. And also we have a project management office, PMO. This group is supporting the project activities and make decision on general forum management matters. So some kind of coordination activities among the projects conducted by the project management office. Yes, and some major decisions should be made in the general meeting. Yeah. And now we have many projects like this. The 24 projects in the XCMF. The variety of the topics. Some of them are 6G, and also we have a millimeter wave local 5G projects, and also NTN, and also many vertical related projects, as you can see. So, yeah, so not only the 6G, we are still active for the 5G promotions also, especially for the vertical industry collaborations. And these 6G related projects, and we are aggressively discussing, studied, and negotiating with key persons, key companies on the NTN aspect, and also 6G promotion, 6G network architecture, 6G radio technologies, terahertz wave, and also space-time synchronization project. Actually, after the establishment of the XMF, we discussed and we established this kind of the project. And actually, this kind of the project activities were started from the last summer. And still, we are aggressively discussing almost monthly manner. We have a meeting and continue the discussion for the deep dive discussion on each topic. And I think that I expect that each project will develop and publish some materials capturing their achievement in the spring and onward. From here, I'd like to explain the 6G related project activities one by one. And first, 6G promotion project. Actually, I'm leading this project. And this, yeah, little bit busy slide, but the main mission role of this project is coordination among the 6C projects, and also especially on the global information gathering and the domestic dissemination, and also promotion of international collaboration. That is the main role of this project. So I'm really happy to collaborate with the 6C organizations in the world. Yeah, many key persons are joining in this workshop, so I'm very happy to discuss on the collaboration. And also international industry academia collaboration. Promotion of this is of course very important, and support for the Japan's activities in the RTO WP5D. Actually, we already developed the white paper in the Beyond 5G Consortium era, and we updated that white paper now as a XEMF version. And also we also developed the white paper supplement. These kind of the supplements are main addressed on the very important topic like end-to-end architecture, self-free distributed MIMO, radio technology, and so on. AI also included. And so this is updated as XEMF version already. NTN promotion project. Actually, we had this group in the Beyond 5G Promotion Consortium, and they developed several kinds of the document like this: scalability working group activity report, and the use case, and the technology roadmap on the NTN. And currently, XMF in the XMF NTN promotion project, updating this kind of document roadmap and understanding, and also and understanding the user needs for the NTN-based communications. They invited the potential users and try to understand their own requirements for the NTN systems. That should be a very, very useful information for us. And also study issues and the solutions measures and the ground design formulations they are discussing and study. Hopefully that this kind of the achievement can be summarized and updated. The updated document will be published in near future. Next, 6E radio technology project. Of course, the radio technology is a very, very key topics in the 6E discussion. And even in the Beyond 5G Promotion Consortium and the other 6E organizations, we identified many, many potential radio technologies for the 6E. But we are trying to have a deep dive discussion on the radio technologies together with the academia people. And the unique characteristics of this project is we are promoting the industry academia collaboration. So in this project, so many academia professors are joining in these projects. And now we have these kind of seven working groups on the each 60 radio topics: device cooperation, repeater and reflector, radio propagation, radio device, advanced MIMO, radio sensing, and the utilization of AI and the digital twin. So for each key topics, radio topics, the working group discussions are ongoing, and academia guides and the industry guides are discussing so aggressively. Yes, so we hope that we can have some good achievement, the discussion result, research results in near future. Network architecture project. And this project mainly focused on the end-to-end network architecture development, and also especially focused on the cloud-native network architecture based on APN, all photonics network, and data-centric infrastructure. And they are gathering the information on the use cases, and they are conducting the gap analysis with the 5G network, and organize the benefit of applying all photonics network and the centric infrastructure technologies, and get and classify the information on concept and activities for the AI native network. Yeah, as you know, yes, AI can be used for the variety of the use cases and technologies for the network architecture aspects. So they are gathering the many information based on the contributions for the member companies and the member people, and classify the information and summarize. Yes, that could be very useful information for the future AI topics for the 6E. Next, terahertz wave. Terahertz is a very interesting topic, but on the other hand, the priority of the terahertz technologies in the 6E discussions are rather low currently. But as you know, this will be potentially treated in the WRC 31, and then potentially terahertz can be used in the middle of the 6E era. Hopefully. So in any case, we should prepare some research and the terahertz deployment to the 6E future. And they currently this project they're discussing on the menu on the use cases and standardization aspects, and use cases and some technologies, yes, or something like that. Yes. Okay, so next, the space-time synchronization project. Sorry for the very small letter. But yeah, space-time synchronization is also very interesting topic, new topic, and this technology can be used for the variety of the industry, and variety of the use cases can be considered. Maybe a 60 radio mobile communications are one of them. And for the future, we will have a communication between the devices without the human, and machine-to-machine, B2B, D2D communication will be deployed more in the 60. If so, it is good to have a highly accurate time synchronization and the position identification. Space-time synchronization could be very useful. So currently, we are sharing the roadmap of this technology and showing the national and the international trend, and developing the strategies for the standardization and providing the platform where the communication related companies which enable inter-device communication, and the companies that utilize us in this communication verticals can meet and exchange information. Yeah. And also, I'd like to explain one of the other project, Odaiba IX Core project. Actually, this is not so 6E centric project, rather than 6E, but 5Z. But we are mainly this project treated the promotion of the millimeter wave and local 5Z, private 5Z aspect. But of course, the millimeter wave use and also private local network could be useful even for the 6Z, and will be advanced in the 6E system. So this Odaiba IX Core project activities on the millimeter wave and private 5Z, local 5Z aspect could be very, very useful, and for the 6Z discussion. Actually, this project will treat the 6Z aspect also, not only the 5Z aspects. Yeah, so I like to introduce this project also to you. And this is closing remark. And yes, in any case, the 6Z project in XCMF will accelerate activities for international collaboration and technical study for key 6Z technical topics. And each project will develop, publish some materials capturing their achievement in the spring and onward. And the XCMS 6G project hopes to have opportunities to sharing the views and collaborate with 6G organizations in the world to facilitate the 6G standardization and the deployment. And as a leader of XCMF 6G promotion project, myself pleased to be a contact window for the international collaboration. So if you have any interest in the collaboration with our project XCMF, please contact me. This email address. Okay, that's my presentation. Thank you for your attention.
Thank you very much for your presentation. There's one quick question in chat. So are these project reports all available in English?
Oh, we will try to develop the English version, yes, as much as possible, yes. But some of them still Japanese only, Japanese version, but we will prepare the English version also. Yeah.
Thank you. Okay, thank you very much.
Thank you.
And now we move on with the agenda. So the next speaker is from the Next Year Alliance. It's Jaydee Griffith.
Good afternoon, everyone. I'm Jaydee Griffith. I'm the Managing Director of the Next Year Alliance. I'm really excited to be with you all here today to kind of share some perspectives from North America on where we're at with 6G development. And I was going to take a little bit of a different approach and kind of talk about where I think we need to go and some of the new directions the Next G Alliance is moving into as we enter into 2025. So for those not familiar with the Next G Alliance, we brought up on several foundational goals. We really wanted to see a North American forum where the private sector, academia, and government could collaborate on how we could position North America as a global leader, working with our trusted partners in Europe and in Asia, and leading next G technologies, beyond 5G as we get into 6G and into future generations. We wanted to develop a North American model for success, built on a lot of the lessons learned from 4G and 5G, but leverage a lot of the American ingenuity in the US and Canada from our research and development, our software prowess, and our involvement in standards development as we kind of prepare for developing a 6G market and seeing how we can move into that commercialization, enable rapid commercialization of 6G, both in North America and globally. I kind of view it as two kind of sides of the same coin. We talk about North American leadership. It's a combination of, we want to, with our partners, be a leader in developing 6G technology. So there's a robust ecosystem of 6G solutions that's available globally, but also that we can be a leader in how 6G is developed and deployed. Can folks not see my screen?
I can see it. Foundational goal.
Cool. All right. I saw someone in the chat. It looks like they might not be able to see it. Anyways, so both it's a combination of being a leader in development of 6G technology, but also a leader in how it's being deployed and used, and can serve as a model for the rest of the world on what can be done with 6G as we move forward. Part of this, and this is what really set the Next G Alliance apart from other initiatives in North America, is how we're taking a life cycle approach to 6G. A lot of folks, just focus on pre-standardization research or maybe on, coordination for standards, but we really wanted to take a full life cycle, what we call the research to realization approach, where we look at the key research priorities for both foundational technology development as well as applications for 6G. What will it take to develop these technologies and manufacture them? How does this impact standards? What needs to be standardized? What are the key areas that we need to see it on day one standardization, as well as in future releases? How do we need to make the market ready? How do we work with the government to ensure that the policies and incentives are in place to make it easier for mobile network operators to adopt and deploy 6G technology in North America, make it easier for consumers to access 6G services, ensure the spectrum's there that will be needed to, for 6G networks to flourish. And then how can we bring this all the way through commercial realization, where we collectively enable the 6G marketplace to meet, policy goals, economic goals, societal goals for, advancing the quality of life in North America. So this is a really ambitious goal and life cycle. The Next G Alliance has done a lot of work. We are entering our 5th year in 2025 of work, and there's been over 30 publications we've put out from paving the way for a North American 6G roadmap, as well as some deep dives into technical issues. You can see the full, all 30 plus publications are available on our 6G library. But here's a snapshot of some of our 4 most recent publications. I am especially excited, just this past week or two, released our Sustainable AI and Telecom, and what the promises and challenges will be in 6G. Our Green G working groups worked very hard on this, and I think it's going to be a very interesting document, given both how popular AI has become in the past year or so, but also given a lot of the very real energy consumption and sustainability challenges those present, and how will that impact 6G technology. Because for years, globally, we've talked about how 6G will be more efficient, better use of resources, better steward of the environment. But, it seems like not just in telecom, but in the entire ICT industry, there's been a huge shift to our greenhouse emission goals or net zero goals have changed now that AI is on the street. We also looked at some other sustainability indicators for next-gen radio network technologies. We've looked at spectrum access mechanisms. I don't know how many of you follow the telecom market in the United States, but spectrum's been a very hot topic lately, as our Federal Communications Commission currently does not have auction authority, and there's a lot of questions about what spectrum will be next available, both for 5G networks and made available eventually for 6G networks. And of course, we've done a lot of detailed measurements and modeling for joint communications and sensing, particularly in the 7 to 24 gigahertz range. But this is a lot of, we've done a lot of foundational work, a lot of aspirational work. As we enter 2025, with standardization going to kick off in earnest this March with the 3GPP 6G workshop in Korea. I really, when I came on board at the end of last summer to NGA, I really wanted to work with our members to take a little bit different view as we enter this next phase. And it's really, I've been involved in 4G development, 5G development, and 6G development, but prior to coming to NGA, my career has been primarily in government. So I've taken a very, outsider looking in and a very comprehensive look. And I see there's a bit of a disconnect between the technology development and where the market currently sits. So I'm sure many of you have seen in the trade papers where, MNOs have had concerns about returns on investment with 5G, about new initiatives where there's been a lack of adoption. Like, oh, we created this new NB-IoT technology, or offer this new, network slicing service, and there's been a lack of adoption. And I think especially as many of us engineers look at it like, oh, well, there's clearly a technical issue that's becoming a part of the problem. But it's taken me a lot of years to understand lack of adoption is not necessarily purely a technical issue. But we need to look at how technology and market impacts, work together or considered together. And then especially if we're looking at business to business services and opportunities, business end users have two goals. They ultimately want to increase their revenue, so they're able to, service more customers, reach more markets, or they're looking to decrease operating costs, whether that be just cutting CapEx expenses, squeezing more out of their budget, making their teams work more efficiently. There's a lot that play into these two metrics beyond just, number goes up and other number goes down. But and this does not just apply to commercial businesses. It also applies to governments. How can they be more efficient in accomplishing their mission, serving the, constituents? Can they stretch their budget dollars farther? So it is not just limited to, commercial business. It also applies to governments and even nonprofit organizations. But I included this excerpt. It's from a Utilities Technology Council report from 2023 on private LTE. Now, for many of us, talking about LTE in 2023 seems like, old news. But this is still, to them, and many other industries, especially North America, that's still what's considered current available technology because of what's available on the market. It's, there's been a slow trickle of 5G equipment beyond typical smartphones onto the North American market. So LTE is still considered, the state of the art in a lot of industries. But even then, with a mature technology, with a lower cost profile and a lot of both user equipment and network infrastructure options, they still have challenges justifying why, it would work in the utilities industry to deploy private LTE. When they look at the challenges, 48% did cite, engineering analysis and RF studies, because these are complex networks. They do have they're not as trivial as some other communication systems. But the majority of the respondents touched on business model, rate case strategy, and justifying the value of such an investment internally. When we look at technology development, we need to look at how our the markets we serve, whether it be as an MNO servicing individual businesses providing a service, or as an infrastructure manufacturer, UE manufacturer, selling equipment or integrating equipment for a particular enterprise customer, or even some mobile network operators that are entering the enterprise services space. We need to understand how this is going to kind of develop the value chain, how it's going to, bring value to our end users. And so I think it's very important that we understand the value chain, because I hear a lot of 6G use cases talking about, very interesting, very advanced use cases, but a lot of the times we talk about things like immersive communications or, uncrewed aerial vehicles, urban air mobility, things like that. We don't have all the right people in the room. We talk about the communication layer, but we don't have the people that's going to build the AR/VR devices for immersive communications. We are not talking with the UAV or UGV manufacturers. We're not talking with like the aeronautical industry in every case. So we're talking about how, the art of the possible. We're only talking about a very small segment of the value chain. So I use this example for agriculture, mostly because I can easily break it down into 4 key pieces. If we're talking about how can 6G enable, autonomous tractors and agriculture use cases to, in the US and especially in the parts of the Southwest, we have a lot of issues with, finding labor during harvest seasons or people who are willing to work out, even in the off season when it's still very toasty in Southern California and Arizona on farms. So there's a huge labor shortage in a lot of, especially in cash crop industries. So if we look at okay, we want to develop autonomous tractors for harvesting or deploying fertilizer, we have to look at, okay, who's going to build that? That's not going to be, as examples, it's not going to be Ericsson, it's not going to be NTT DOCOMO, it's not going to be telecom companies. It's going to be your John Deere's, your Klosses, your Agcos that are going to develop those vehicles. Now, if you have the vehicle and you look at, okay, we're going to provide a wireless link, that's very much in the telecom industry. We're from the transport network to a cloud service or an edge computing system. But then who's going to write the software to monitor, control that vehicle? It's not going to necessarily be the telecom industry. It's going to be an agriculture vertical industry. So how can we bring this value chain together? Because right now we talk a lot about this middle section without factoring in, who's going to build, how are they going to build it? How do we ensure we're giving, the agriculture vertical industry in this example, the tools that they need to maximize, the capabilities they have at their fingertips using 6G or even 5G networks. So with 5G advanced, this is kind of, I see Mitch saying, posting a lot in the chat. He's, we talked quite a bit about this particular market issue. And he's, heard me in many Next G Alliance meetings where we talk about oh, well, this feature was available in 5G. I usually make a very pointed comment of okay, cool. Show me where it's deployed in the real world. Because there's a very big disconnect I've seen, and many of our members have seen in, what enters into standards and what has been able to make it out in the real world in commercial products. So I really, ask these questions to a lot of our members who've been working on 5G Advanced. Have we really engaged the right stakeholders? Have we worked with our end users to validate that the technology we're developing, whether it be 5G Advanced or 6G, meets their goals? And do we have the correct supply chain in place? If we do develop this feature or this application or capability, is there actually someone to sell them a product that they can build into that autonomous tractor? If we answered no, well, how are we going to fix this for 6G? Because it isn't just going to, magically resolve itself. So I really, make this point. It's going to 6G, for it to be, successful both technologically and commercially, it will take a village. You need to bring together the suppliers for user equipment, and the RAN and core infrastructure networks. You need to bring the mobile network operators together. You need the end users, and I do think there's a big opportunity here for a nascent systems integrators market, especially as we see a lot of the ICT community move to a, insert term here as a service model where, especially corporations, they don't want to have to, except the largest corporations who can realize, the minute economies of scale here can actually or the minute gains from piecemealing it themselves can turn into economies of scale. Many businesses are looking for, I want to talk to one entity, I want to pay them a single monthly subscription, and I want them to kind of figure out how to piecemeal, the communications network, the user equipment, the monitoring and dashboards and control system all together for me, as we've seen in many other industries for industrial control, in the cloud sector, in the other software industries. So this will really take a village. And, I'm really excited that, Next G Alliance will actually be later this month hosting a workshop with some vertical industries so you better kind of understand what some of these, what their end user goals actually look like. How can we ensure that 6G will be built with them in mind and that they can meet their needs, not only the needs of today, but the needs of tomorrow, and short circuit this very long kind of innovation cycle we've been seeing with 4G and 5G networks. So it isn't necessarily, many years after deployment that we finally see entrance into some of these new markets that, day one 6G can support as much, support as many of our end users as we can, not just consumers, but also many of the businesses and industries that, we support, but also our, economies and societies depend on, like agriculture, like utilities, like public safety. So I'll stop there and, happy to answer any questions that folks may have.
Thank you very much, Jaydee. Very interesting. We have time for one quick question. Yeah, there's comments in the chat, but no questions. Comment from Contalera. System consulting entity can provide this end-to-end service delivery and management. So,
yeah, no, I think that's not. That depends on the end user, and every business will want to handle it differently. Some will want kind of that managed service provider type of approach where they pay the monthly fee. Some will want to, I'm happy to operate the network, but I want someone to design and build it and show me how to use it first. I don't want to have to staff up my own team of engineers just to design a single system, that sort of thing. So yeah, there's a lot of, I think, flexibility in what kind of fills this gap between the MNOs and the end users in cases where it may not make sense for the MNO to, do all that integration and value-added reselling themselves.
yeah. So now we're out of time. So if you have more questions, please place this in the chat. Jaydee can respond to them. Need to move on with the agenda. So next speaker is the one that should have been in the previous session, but we had a change in the agenda. So now it's Liu Guangyi from China Mobile, discussing the end-to-end system view and architecture from the Chinese perspective.
Thank you, Patrick. Thank you for your invitation and the introduction. Sorry, and also missed my session in the morning. And can you hear me and also see my screen?
Yeah, we can hear you. Go to presentation mode. Yeah, looks good.
Okay, so and good afternoon and good evening, everyone. I think I'm Guangyi from China Mobile, and also I'm the vice chair of the wireless network group of MT 2030 promotion group. Today, I'd like to share some ideas and also observations from especially from Chinese perspective. My presentation has three parts. The first one is the challenges faced by the ecosystem in China, and the second, I will just introduce you the innovative design for 6G networking from China perspective, and also finally give you a summary. Based on the observation for the current status of the, we do see we are facing many challenges. The first one, of course, is the existing business approaches, the bottleneck, especially take China Mobile as an example. From year 2024, we do see our data traffic volume start to decline due to the AI application by the OTT players for their for their video data rate compression. I do believe for such kind of situation will be even worse if the AI's application in the source coding and the decoding will make good progress. So for us, we have to consider how for the future network can really help us to change such kind of situation and create new values for the mobile operator. Of course, the first one, of course, a potential way is to cultivate the new service, new application, and also new business model, like the AR, VR, like the intelligent robots, and also the UAV, etc. A second one, of course, is the how to create increase growth grow the value of the existing business, like voice, like data, and how to help to duplicate the applications for the vertical industries, and also to cultivate a ladder curve for the revenue growth. So the second challenge, of course, is towards the year 2030, we do see we will have even more differentiated scenarios which demands even more diverse requirements. Here are just some examples like the intelligent robots, like the UAV, like the immersive communication, and also satellite, etc. From all of them, you can see they demand different capabilities from the network. So for 6G, one of the important capabilities is how to adapt to the specific and diverse scenarios and monetize the network's capability. The third one challenge is the bottleneck. We have approached the bottleneck of the area interface performance, especially for the commercial network of 5G. We do see we have observed the larger gap in the experience data rate between cell edge and cell center, and also between the uplink and downlink. For future, we do believe even the cell edge performance and also the uplink performance will be the bottleneck of the service providing, especially for the new services for higher data rates, etc. The fourth challenge, of course, is we have the learnings from 5G. For the large-scale development of 5G networks, we do see we are facing the challenges from the high cost, high energy consumption, and high complexity in the operation and the maintenance. All these are the pain point of the 5G networks. So based on these observations on the challenges we are facing, we do see for 6G design, we need to take fully account all these aspects and to introduce the innovative design for the area interface and also system architecture to really to address these issues. So in principle, the drivers for the 6G mobile network, of course, is the just we have mentioned the challenges, the new requirements from the usages and new usage scenarios, etc., and also the key points to address these issues, including the coordinated master MIMO to provide the balanced performance, and also the coordinated multi-bands to provide a green deployment for the network and reduce the cost of the network deployment, and also the cooperative sensing to provide us low cost and ubiquitous sensing network. From the network architecture perspective, we need to help the mobile operator to, especially to create more pipes to earn money for the new use cases and the new scenarios, like the besides the communication as a service, we can also have for the data as a service, computing as a service, even AI as a service. And also to address the high complexity operation and maintenance, I think we definitely need autonomous network functions at the day one deployment. To really achieve this, we do believe the digital twin network and also native AI design is the key to really achieve zero fault, zero interruption, and zero wait. So from the system design perspective, I think comprehensively, we do see for future, from the mobile operator perspective, a unified design for all scenarios is expected. For example, we can just decouple the requirements from different use cases as three parts. The first part is a common requirements, and also we can have for the differentiated network requirements and also differentiated service requirements. So for the system design, we can have first we can have a minimum kernel of the common functions to really address the common requirements for all the usage scenarios. And also for the specific and individual use cases, we can introduce additional functions like I have shown here. For the immersive use cases, we can have for function A and B. For others, we can have some other functions. based on such kind of design, of course, we can just deploy the network, the customized, personalized network for the specific use cases based on the common platform, for example, the cloud. So by this way, you can see we can even orchestrate and integrate the different functions together with the common functions to provide the customized, personalized network deployment for the individual use cases. By this way, we can minimize the cost and also make energy consumptions for such kind of service providing. Regarding the unbalanced performance in the uplink, downlink, and the cell edge and cell center, we do see we need to pay more attention to the coordinated muscle MIMO. Even in 5G, we already have such kind of specification, but unfortunately, due to the bottleneck of the eCPRI interface and also the architecture of the muscle MIMO base station, the coordinated functions cannot be introduced in the current 5G networks. So for 6G, we do see we need to consider these issues from the day one deployment, from the network base station architecture, and also from the function design perspective to make sure we can have the coordination among different sites to guarantee the users always have the good signal and good SNR. By this way, we can just really guarantee we can improve the performance, not just at the cell center, but also at the cell edge. And also, for the muscle MIMO, we also need to consider the AIS power, how to use AI to further improve the performance of the muscle MIMO. I think it's also a hot topic. So there's two examples. So we do believe it could be profitable. For example, the first one is how to use the AI to compress the uplink feedback and guarantee the performance. Here's some examples and some simulation performance. You can see it really has the potential. A second one is how to support the AI-based MIMO precoding, and also based on such AI-enabled MIMO precoding, it also has the potential gain to improve the performance of the system. And also, typically for the mobile operators, we do have multiple bands, lower bands, mid bands, even higher bands. So how to make full use of the profit of the different bands, I think it's also a very important issue for 6G design. Here, just give an example, and we can just decouple the control and data link. We just for example, put the control link on the lower bands and provide the always-on deployment. And also, it can achieve very good coverage and a very good power energy efficiency. And also for the data link, we can put it on the mid band or even higher band. By this way, we can provide a very large data rates and also large capacity. And also the database station can be dynamically switched on and off according to the traffic load in the network. By this way, we can also share the hardware of the processing for the database station, and also we can just switch off the base station when it is there's no service on it, and by this way we can also reduce interference among the database station, and thus we can also improve the performance of the data link. Another very important hot topic is sensing. Of course, traditionally we just use one base station to transmit and receive the reflected signal to capture the sensing results. By this way, we have to consider how to handle the serious interference between the transmitted signal and the reflected signal. So typically it will degrade the performance of the sensing and also introduce extra complexity for the base station implementation, and also need to higher capacity cost for such kind of base station implementation. So a direct idea for the network, mobile network sensing is that we can just use one base station to transmit and the other base station to receive the reflected the signal. By this way, we can avoid this self-interference, and also we can have the diversity among different receiving base stations. By this way, we can further improve the performance of the sensing, and also we can just simplify the base station's implementation. From the system architecture perspective, of course, I think we just like I have mentioned before, for 6G we need to enable new services besides the traditional communication, like the data as a service, computing as a service, AI as a service, and also maybe security as a service. By this way, we can provide more pipe for the mobile operators and help them to enable the new service, new applications, and also grow the new revenue for the new pipes. To really achieve this, of course, we need to consider how to introduce the, especially the end-to-end protocol and mechanism to guarantee the service quality of all these new applications. For example, here we can just introduce the data plan, computing plan, intelligent plan, and or even the security plan to support the new content of the services. The potential solution to really achieve this is we can inherit the service-based architecture from 5GC. We can introduce the new new plan like the data, computing, security, etc., as the individual decoupled services. And also even from the radio access network, we can also use the service-based architecture to redesign the current protocol and mechanisms. By this way, you can see it will be very flexible for us to orchestrate and integrate the corresponding services and functions together, and integrated with the corresponding hardwares. We can provide a customized, personalized deployment for the individual use cases. Here is some example on the service-based radio access network design. We can have some partially service-based interface. We can also have a complete service-based design. Like for example, here we can decouple the different functions, protocols, and the different services, like what we have done for 5G core. So based on this SBA, I think it will be very easy to introduce the data plan design to the network. The target of the data plan is try to provide a comprehensive data management system to provide any data from the, we can connect the data from the UE, from the base station, from the even core network, transportation network in an on-demand way. And also this data can be shared among different network elements, and also even among the different vendors. By this way, you can really help us to support, I think, support more AI use cases in the network, and also for the users, for the users and their services. To really achieve that, I think we need the data handling functions, data processing functions, and the data storage functions to be introduced in the network. And also similar design principle can be considered for the computing plan, and also for the computing plan, AM plan. For the meantime, I don't like to touch it in more detail. And also based on the design above, we can see we can, one thing very important is we need to consider how to help the mobile operator to cultivate more service and applications. So a rough idea is we can learn from the current OTT players like the Taobao, like the Alibaba store. We can just make the network as a platform. We can expose our network capabilities to the third party or external players. Based on these capabilities, they can they can create their own service and applications and deploy them on the mobile network operator on the mobile networks, and then serve for the mobile operators customers. By this way, we will not based on this idea for future, we will. I think not only the OTT players and the mobile operator can provide the service, created service, and also more and more players can be involved in the service innovation. By this way, I think we can help the mobile operators to monetize our network in a better way. The last one, I think, is very important, is the autonomous network. I think it's also always our dream for the mobile operators, try to reduce the cost for our OPEX. For 5G, we have achieved level 2 and level 3 autonomous. For 6G, from the day one, we hope we can have the fully autonomous network, like what we have mentioned, zero weight, zero touch, and zero fault. To really achieve this, we do see we need support from the digital twin network and also the native AI design in the network. Here, just give you an example of the concept of the digital twin network. It's just a digitalized virtual network. We can provide a virtual network environment. Based on the environment, we can just simulate the network behaviors, performance, or procedure, and also even we can verify the strategies and also optimization solutions in the digital network, and make sure it can really achieve what we expected. Then we load or configure it to the physical network. And also, this virtual network environment can be used to create the data for the AI training and also to verify the AI's performance, etc. By this way, we can avoid the high cost for the trial error in the network. Here is the whole picture of the framework of the 6G autonomous network. Here you can see we need the centralized distributed deployment of the digital twin, and also we need the individual domains autonomy, and also we need the cross domains autonomy, and we need also the closed loop, especially closed loop control is also necessary for the autonomous network's real operation. So finally, I just give you a summary. I think from the current status of the mobile industry in China, we do see the existing best model has met the bottleneck, and 6G definitely need to create new values like the new pipe, new capability pipe, new use cases, and even new business model. To further improve the performance of the air interface, we need the coordination among the multi-sites and also multi-bands to really provide the balanced performance in uplink and downlink, try to avoid the bottleneck for the service providing. And also we need to consider to introduce the cooperative sensing to really provide a low-cost, accurate, and ubiquitous sensing network. And also from the 6G system architecture design perspective, it should be designed to enable X as a service. The X means communication, data, computing, AI, security, etc. By this way, we can provide more pipe for the mobile operator to cultivate the new service, new application, and also the new value. And also the platform network is the key to monetize the network capabilities for the diverse scenarios and also cultivate more new innovative service applications for 6G. And finally, the digital twin network and native AI will enable autonomous 6G network and help the mobile operator to really to control the OPEX of the network deployment. Okay, that's all my presentation. Any question, comments are more than welcome.
Thank you very much, Guangyi. So in the interest of time, if you have any question, please place these in the chat. Guangyi can respond to them. Moving on with the agenda, The next presentation is from the 6G ANA project with Gerald Kunzmann.
Hello, everyone. Hi, Patrick. Thanks for the invitation to give an update on our sustainable and secure architecture and system design. I had already the opportunity to present in the earlier meeting in the UECNC event last year. And so I would like to give a bit of more details and insights compared to that presentation. Yeah. Still, let me first do a quick recap. What is the 6G ANA project about? So 6G ANA is an abbreviation for 6G Access, Network of Networks, Automation and Simplification. And that very well describes also the main work areas of the 6G ANA project. Yeah. The 6G ANA project is part of the larger German 6G platform for future communication technologies and 6G, so a German-wide coordination platform for different research projects, and the 6G is the lighthouse project in this consortium. Our mission is to develop a blueprint for a functional 6G end-to-end system that is designed for energy efficiency, security, resiliency, many of these KPIs that we have already heard a lot about today. And it's aiming to improve also the interaction between human technology and the environment. I've also included here in the slide some of the use cases that represent quite well also the scope and also the partners that are involved in the 6G ANA project. So this is vehicular mobility, public safety, mobile XR, digital twins, and collaborating cyber-physical systems, like a robot or HEV. And yeah, this, as I said, this also shows quite well the consortium. So we have 7 industry partners from automotive, from different industries. We have small, medium enterprises, research institutes, universities, and 3 associated industry partners. And jointly, we are working towards coming to a common understanding of what the 6G era should look like. And my specific area that I'm looking into is the architecture. So I'm leading the 6G architecture and system design work package in the program, in the project, as well as corresponding activity in the 6G platform. When we started the project, I mean, one of our first steps was to think about, okay, what were the lessons learned from the 5G? What will be the recommendations or the design principles that we want to utilize when developing the 6G architecture? So I have listed here the key ones on that slide. So it should be a single standalone architecture. We had seen with 5G multiple different deployment options being standardized, resulting to a lot of complexity, effort, and in the end, not all of the deployment options have been used, and even complicating also the introduction of 5G. Hindering even to some extent also the 5G standalone introduction. Then as we are moving towards a more softwareized and also cloud area, the 6G network should support, of course, a cloudified radio access network. But we still see that a lot of companies or CSPs also want to follow this legacy or distributed run approach. So both of them should be supported going forward. And then we see advances also in different technology areas. So we want our 6G system architecture to be AI native, to be cloud native. And as also other speakers today have already mentioned a lot, so it's a lot about also exposing information, about making the network programmable. So also it should be API native. Then we also said we will not start from scratch. No one wants to pay for coming up with a completely new 6G system design, but we want to follow a bit more evolutionary approach, but still not limit us to a pure evolution, but allow where necessary or where also well justified critical enhancements to introduce new 6G services or to optimize the system and its performance. If you look at the figure that I have depicted here on the right-hand side of the slide, you see that it looks almost like a 5G system from that high-level view. So we follow, again, this very clear domain and layer separation that is very beneficial. So we want to abstract all the complexity of the underlying layer. So the infrastructure, this is quite heterogeneous. We have cloud, so many different platforms and device types and so on. We want to really abstract it. Then on top of that, there is the more 3GPP oriented functional architecture with the radio access network, the UEs and the core. And on top of that, before the consumers, there's a value-adding network platform that can be introduced here, which allows easy access through specific network APIs, so that the developer of a third-party application doesn't need to know all the complexities of the underlying network, but can use lightweight APIs to interact with the network. Then one other area was also that we wanted to make sure that we simplify or also focus on most important aspects from the 5G area. Here, the fourth bullet item is about focusing on key standard interfaces. So we were rethinking from all these standardized interfaces that we had in 5G, which of them were really used in the industry. Where does a multi-vendor choice bring significant benefits, outweighing also then, of course, the required complexity and effort that comes with standardizing and making sure an interface is really interoperable between different vendors. And then not to forget, I mentioned about AI native and different technology advances, but then also going forward, we need to increase also on the sustainability aspect. So mainly here in the project, we look more at this environmental sustainability aspect. So reducing overall the resource, increasing the resource efficiency in the system at all possible layers and domains that we are touching. Let's zoom a little bit into more the 3GPP-centric view of the 6G system architecture. So this is an exemplary figure. Only the release 21 specification will then tell exactly how that will look in the end. But this is our 6G ANA view. You can see here, maybe starting from the right-hand side, a core for 6G that is following service-based architecture as we have in 5G. Then I mentioned that we have the multi-vendor interface towards the RAN, the baseband unit. And then moving a bit further to the left, lower layer split to the RU, and then two exemplary 6G UEs depicted here in the figure. Maybe what is new, that was also one of the big aspects of the 6G ANA project, is this network of networks that is depicted here in the figure on the left-hand side. So the 6G subnetwork as one realization of a network of network, where we have a subnetwork controller. It could be enhanced UE, but could also be a dedicated device that is spanning up a 6G subnetwork where different devices can register. Those devices can either use the same access technology, also 6G access, or there could also be other non-3GPP access that is being supported in this subnetwork. And the speciality of this subnetwork is that in case the connectivity, the coverage between the subnetwork and the parent network here on the right-hand side is getting broken for different reasons, then this subnetwork can partially continue to work or operate in an autonomous manner. Different autonomy levels can be considered here, where maybe the operation of the network is quite limited to a almost fully operative subnetwork. And the use cases for this are quite diverse. So, this could be for a disaster case. This could be to increase the resiliency of the system. A subnetwork could also be a car. The car is entering a tunnel, losing temporarily the connectivity to the overall network. But if you have different sensors in the system and multimedia devices in the car, then of course this connectivity should not be lost during this interruption time. Yeah. Another use case could be that a subnetwork is spanned on your body, meaning that the devices in the subnetwork are devices that you carry around, like health sensors, your smartwatch, other gadgets that you have, and your UE is then acting as the subnetwork controller in that case. Yeah. If you enter a house, a garage, connectivity to the parent network might be lost, but you still want to make sure that those devices can talk to each other in the subnetwork. And once the connectivity to the parent network is reestablished, then of course also any state or changes here need to be synced again with the data stored in the parent network. In the next slide, I will look a little bit more into the 6G run function. Here, this is also again a functional architecture. The idea is to abstract from any implementation or deployment specifics. And this run function that is now depicted here for the parent network could also be applied to the subnetwork controller. So the subnetwork itself could be also almost kind of full 6G run itself. Maybe you noticed that there are no interfaces depicted within the 6G run function here. So following our design principle, we really would like to focus on selected open interfaces. That is the UU interface between the 6G UE and the radio unit, the lower layer split between the RU and the baseband unit, which is done in a stateless manner. And then you have here the 6G XN interface that is to support mobility for the UEs. You might notice that from a 6G ANA view, we don't see a strong need to introduce a higher layer split, so this is not being shown in this figure. When it comes to multi-connectivity, this is being realized by a carrier aggregation, not by dual connectivity. This means that the UE connects to only one run at a time. Then also following our other design principles regarding simplification, for example, we want to make sure that here in the 6G run, we follow a lean protocol stack to save memory processing, to also reduce the latency. But then also this memory and processing savings would help to reduce the overall energy consumption of the run function. The different building blocks of the baseband unit all are being enhanced. For example, the radio resource management is being enhanced to support contention-based uplink. We introduce also following our AI native design principle, we introduce or we realize it with an AI-based mentality. We enrich certain information that is being stored or exchanged in the run. And also we introduce new and improved energy efficiency features. Also for the file layer, there are several evolvements, including flexible OFDM and a more massive MIMO. When it comes to working jointly in the same area like a 5G network, here we suggest a multi-rad spectrum sharing MRSS, which is kind of a successor of the dynamic spectrum sharing DSS that we had in the 4G, 5G situation. Let's then look again on some other building blocks. In the next slide, we will look into the core part, as is being depicted on the right-hand side of our end-to-end figure. And you can see that in the core, we still follow the service-based architecture with the different network functions. And you will immediately realize that also here we have two categories of network functions. So you will see a lot of familiar names here, UDM, NRF, NEF, PCF. So there will be a majority of network functions in 6G that is being shared with a 5G system. So these network functions can serve 5G or 6G UEs. Those are continued to be used and they follow a regular evolution path, meaning that from the release 19 specification, we will go to release 20 and we'll go to the release 21 specification in a real evolutionary manner. And then there's a second type of network functions, and this is what I meant before with we also want to allow for innovation in the 6G area. So dedicated network functions to support 6G UEs. And here basically two subcategories. So we have network functions like the session management or mobility management. These network functions are being adopted from their 5G counterparts, or we could also say they are being forked from a software viewpoint. based on their 5G counterparts. And this is, for example, done to optimize the system design and the performance, to, for example, optimize the functional or the functionality split between the different network functions and reduce thereby signaling between those two entities. But there can also be another category here depicted as new NFs. So we will see introduction of new services in the 6G area. One example could be this joint communication and sensing, and there would be the need to also then have a network function that is supporting this new service for 6G. In the next slide, I would like to show a little bit more how then this shared NF concept is being used to support the interworking between the 5G and 6G. So far, we have been looking at a 6G only system, but let me rearrange a little bit here the network functions and bring into the picture also here depicted in green the 5G specific parts of the system. So yeah, as I said, we have the 5G specific counterparts, AMF, 5G RAN, and other 5G network functions that are not important now for the context of the interworking. We have then on the right-hand side the 6G or the network functions to support the 6G. That could be the 6G mobility management function and other 6G network functions then, as I said, supporting or serving 6G UEs. And then we have here in the center the shared network functions like a UDM or NRF that are being used to support or to serve both 5G and 6G UEs. We want to have a system where we have a single registration, so the UE registers to the network, not with a dual connectivity, but registers only once to the network. And this single registration-based interworking is then supported between 5G and 6G. This interworking needs to be mandated for all the UEs that should be able to roam here or to move in this coverage of this 5G and 6G system. And in order to support the mobility when the UE is moving, the mobility between the 5G and 6G, we need to do certain measures. First of all, there is certain context stored in the AMF, for example, that needs to be transferred to the 6G mobility management function when the UE is moving to the 6G and vice versa if it's again leaving the coverage area of the 6G. Then there is also information exchange needed to ensure seamless service continuity. And in particular, it is important or necessary that the same instance that is serving the user in the 5G domain is also continuing to serve the user then in the 6G part. So this is why, or this is being realized by concept of combo, which we have also, which is a known concept already from 4G, 5G, where in a single product, then both the 5G and the 6G counterpart are being implemented. And then a single instance can serve the user independent of whether the user is currently in the 5G or in the 6G coverage area. Same for the UPF. Also here, a common UPF IP anchor is needed to make sure that we have seamless service continuity when there is mobility between 5G and 6G. And of course, some additional handover support is also needed then between the 5G radio and the 6G radio to make this interworking possible. Let me wrap up my presentation with a short summary. So 6G will push boundaries on key performance indicators. So we will see a superior radio performance. We will see extreme energy efficient solutions. It will be AI native, it will be programmable, it will be quantum safer. But also we want to prominently address new major factors like sustainability, digital inclusion, and so on. I have introduced the key design principles of the 6G architecture that based on the proposal that we have are being followed. So a single lean and future-proof standalone architecture that is based on a 5G system, but allowing still innovation and critical enhancements for new 6G services, following a clear domain and layer separation, focusing on those interfaces that are key to support multi-vendor deployments and to ensure that the system has increased environmental sustainability at all the different layers and domains. Finally, I mean, also following what other speakers have been saying today, 6G presents a big opportunity to make our network more programmable. By that, also to make it more monetizable, not at scale and with a global reach. And also, this whole concept and this architecture should provide a holistic support to also introduce or make some of the use cases that we have already seen in 5G to really generate value now in the 6G area. Thank you for your attention, and yeah, happy to take any questions if time allows online or otherwise in the chat there.
Thank you very much, Gerald. I think we're running a little bit late, so any questions would have to be in the chat.
Okay.
Thank you very much. We can move on to the final presentation of today. So it's from the 6G end-to-end project with Nicolas Schubert.
Okay, thank you, Patrick. Can you see my slides?
Yeah, go presentation
okay,
mode.
Great. Okay, excellent. So I'm going to give an additional perspective focused on non-terrestrial network in 6G context. It's a project that is going to run until the 21st of December 2025 and focusing on the NTN component and driving the initial standardization step in 3GPP. We are addressing two family use cases, basically, that correspond to two types of satellite network. The first is providing satellite connectivity to smartphone and IoT devices in frequency bands up to 8 GHz, and the challenge is to increase the performance compared to 5G in terms of data rate, but also coverage and throughput. The second is to consider the connectivity to vehicle building mounted devices, and the challenge is to be able to address very small antenna aperture adapted to vehicles, but also drones and so on, which is quite unusual in the context of broadband satellite systems, and they operate above 10 GHz. The service requirements based on the use case we have analyzed can be summarized into improved user experience, and there is a desire to improve the service continuity to make it quasi-seamless, especially in connected mode between NTN and terrestrial network. Improve coverage, the capability to address user equipment in light indoor and in-vehicle conditions. Mobility in harsh environment like suburban and dense forest, where you have deep fades of several hundred milliseconds that can be, so you have to cope with. The support of device diversity, and improved data rate and throughput, as I discussed earlier on. In terms of network capabilities, these are related to, the focus is on resiliency, and we want to introduce some GNSS independent operation on the satellite network, especially for the initial access, but also for the other modes. A GNSS independent capability for the UE to determine its location using the 6G radio interface with some additional information, so some assistance information, and the service continuity with respect to a temporary failure of a given node because we're talking about a multi-layer architecture with satellite at geo, at non-geo HAPs and terrestrial nodes. And the last is to be able to set up quasi-autonomous network over a specific region via satellite with no or intermittent connectivity to core network in order to respond to crisis. In terms of sustainability, we advocate that one way could be to explore how to minimize the overall consumption of the system by selecting appropriately the less energy consuming access network under traffic or even under zero traffic condition. So this is obviously the NTN and terrestrial network have different characteristics in terms of energy consumption profile, and this could be exploited to minimize overall consumption, energy consumption. And the last is about the overall spectrum usage efficiency, given the scarcity of spectrum. How can multi-access technology can coexist better in a given spectrum? We have here the performance target that we are trying to consider for the different use case I've mentioned. So direct connectivity to smartphone or vehicle or drone mounted devices, large aeronautic and maritime platforms mounted. As you see, the performance are no way near what terrestrial network can achieve, but the NTN added value is clearly in the coverage extension and resiliency contribution. Last, there is the need to be able to work on the location service and to be able to consider GNSS independent positioning techniques. Would hello? Can you imagine? Can you?
Now I can
hello?
hear you.
Yeah?
I lost it for a bit there, but now I can hear you.
I lost a few
Okay,
seconds, but your audio is back.
Okay, I'm sorry. But to achieve that, we would like to introduce some extended maximum coupling loss capability in order to address this harsh environment, but of course at the expense of the service rate. But that would be very of interest, especially for emergency services or public warning service. Okay, there is here, it's a nice illustration of what could be the 3D network concept. Given the different characteristics in terms of coverage, in terms of capability on board between GSO and GSO and so on, the idea is to be able to exploit these different characteristics to move the UE, for instance, to the GSO layer if they are in idle mode, and to the NGSO layer if they are in connected mode, for instance. That's one example. And also how to minimize the energy consumption on a certain layer by transferring to another layer. So these kind of techniques are being considered. In terms of architecture, I'd like to give a little bit of highlight on typically the most, I would say, straightforward approach would be to say, okay, the satellite is just a bent pipe, and it's just to receive a RF signal with modulation and just repeat in a different frequency band, and that's it. So that would be the transparent RF payload. But some people would like
I guess we lost Nicola again for a moment.
Yes.
Are you and
we lost you for a minute.
Yeah. So I mean, this is the desire. However, satellite are highly constrained in terms of power that are available on board, the processing, and so on. So there is a careful design that needs to be defined to not eat all the power of the satellite just for processing with digital processing, because what makes the performance of the satellite will be the RF part. And so some other approach would be to maybe put a little bit of processing on board, because you have another constraint is that you don't want to maximize the bandwidth on the feeder link. So there is a balance to take, and another approach that we have considered in the project was to maybe consider that there could be some feeder satellite embarking GNB with a lot of processing, with while there will be a service satellite that would be optimized to deliver the performance. So this kind of architecture consideration are of importance in order to advocate for maximum flexibility in the 6G system architecture, so to allow to select the appropriate functions that to be on board while maximizing the performance of the satellite in terms of capacity and throughput. So here we don't expect at all to have a 6G radio interface dedicated for NTN. We'd like to have the same radio interface between TN and NTN, and that would really allow to take benefits of the combination of both access technologies, knowing that obviously the terrestrial network has much more performance, while NTN is more appropriate for coverage areas with low density populated areas. So here in this table, you'll find a long list of features that we'd like to introduce in the 6G radio interface, so to be able to support NTN from start. Well, some of them could be introduced from start, some may be introduced a little bit in future release. But the first fundamental is to have the same waveform, the same basic physical layer that would be able to cope with the TN, but also the NTN specific constraints. For instance, Doppler, latency variation, but also the, if possible, reduced peak to average power ratio on the downlink in certain configuration of the radio access network. We believe that the 6G could be a way to improve the performance under low SNR conditions, so to reduce the need for HERQ, which introduce some delay, and especially in satellite, this has a high cost. Also, to be able to support extended maximum coupling loss would be beneficial, not only for NTN, but also for terrestrial network, because the challenge is to address to support ubiquitous connectivity even in very harsh environment. So maybe light indoor for NTN, but also deep indoor for terrestrial network. Given that the channel propagation model is is quite different with respect to TN, because there is no multipath. Maybe we can introduce some flexibility in the framing structure, so to maximize the performance in the TN. We would like also to introduce some positioning, navigation, and timing service that would be RAT only, based RAT only, so without GNSS. By the way, we want to introduce in the 6G radio interface a capability to operate in some cases without GNSS, so to be more resilient with respect to the potential unavailability of the GNSS service. Support of broadcast and multicast is obviously something of interest in NTN. And the enablers for artificial intelligence-driven radio resource control is something of interest. We believe that the algorithms are going to be different because of the latency, which is much greater than in terrestrial network. But probably there could be some common interest to expose some measurements to higher layers. Spectrum sharing, it's something also to be improved because of this spectrum scarcity. There is a chance to get more spectrum at the work 2027, in which the NTN 6G NTN could be deployed. And last, given that there are some allocation, satellite allocation for unpaired and paired spectrum, we believe that FDD and TDD-like mode should be supported by the 6G NTN. So, as you see, there are a certain number of features that could be are going to be very beneficial. What is fundamental is from day one to be able to be NTN somehow ready at the most lower layer of the radio interface. So that we don't end up like in 5G where NTN was added after 2 or 3 releases with a lot of constraints. We managed to cope with lots of constraints, and this makes the 5G NTN very good. But okay, there is with 6G possibility to address new service target and operation optimization. Thank you. That was my. Can you hear me?
Yeah, I can hear. Thank you very much. So we're at the top of an hour, but if there's any questions, we can quickly take them. If not, then I will thank you, and thanks to all the speakers. The sessions will continue tomorrow, both in the morning and the afternoon.